Problem 15. You're almost finished with the test. You feel like quitting, but don't do that. You can do this problem. I've got an experiment, and I've got a population of bacteria tripling every 4 hours. At the beginning of the experiment, when time is 0, there are 200 bacteria. The first thing they ask you to do is just calculate the value of A. And you can see that. All right, where's my little pen here? Come here, come here, come on. You can see that we're multiplying by 3, multiplying by 3. So you know that for part A, you're going to take 600, you're going to multiply by 3, and you're going to get 1800. Now you're feeling a little more confident about the rest of this problem. How many bacteria will there be after 1 day? Well, you could write an equation for this or come up with a formula, but truthfully, I think at this point it might be just easiest to say, okay, at 16 hours, you've got 16,200. 1 day is 24 hours, so we're going to figure out after 20 hours and then after 24 hours. So I need to multiply times 3, and then I need to multiply times 3 again. So just putting that in your calculator, after 24 hours or 1 day, there will be 145,800. Now, by this time, you've figured out that this is an exponential function, and you remember that exponential functions are generally in the form y equals a times b to the x, where a is the initial value, b is the multiplier, and then x is our variable. And if you kind of look back at the table, that makes sense. If you take 200 to the power, if you take b, the multiplier of 3, times to the power of 0, that's 1, times 200 is 200. So our formula for our equation is going to be y is equal to initial value 200 times 3, our multiplier, to the x. And again, if you had come up with this equation in part B, you would just substitute 24 into for x, 24 hours is 1 day, and you would have ended up with the same answer. What they want us to do in part C is to figure out how long it will take for there to be 2 million bacteria. 2 million bacteria. 2 ways to do this. What I think is probably the easiest way, in your calculator, and I want you to show this equation though so that you'll get full credit. In your calculator, you're going to say, well, when the heck is 2 million equal to 200 times 3 to the power of x? In your calculator, you're going to go over to y equals, let's just get my calculator, ooh, where'd it go? Get my, that was scary. I'm going to put in y equals 2 million into y1. Now I'm going to say, well, when is that? I think I have like way too many zeros here. 1, 2, 3, 4. What happened? It went crazy on me. Let's clear that out. 2, 1, 2, 3, 4, 5, 6. When is 2 million equal to, and let's put our function in, we said we had 200 times 3 was our multiplier to the power of x. Now here's what you have to remember. X stands for every 4 hours. We're going to come back and talk about that in a minute. I want to find out when these two graphs intersect. These graphs will intersect when they're equal, but I have got to change my window because I know that my y max has to be at least 2 million. I'm going to be graphing that horizontal line at 2 million. So I'm going to make it at 2,100,000. 2,100,000. Now I'm going to graph my two equations. There's my 2 million. There's my exponential function, and I want to find out when those two are equal to each other. Second, I'm going to hit calculate. 5 is the intersection. I'm going to do enter, 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 and it tells me when x is 8.38. Now, 8.38. But what is 8? I'm going to write right here. When x is equal to 8.38, but remember x stood for every 4 hours, so I need to multiply that by 4. 8.38 multiplied by 4. I have my handy calculator here that you can't see. 8.38 times 4 is 33.52, so 33.5. So after 33.5 hours, we'll be at a population of over 1 million after 33.5 hours. And that concludes the May 2008 Paper 1 IB Math Studies exam.